Hi there! Today we would tackle three sorts algorithm, mainly merge sort, insertion sort, and quick sort. Merge sort. A divide and conquer algorithm that splits the array into halves, recursively sorts each half, and then merges the sorted halves together. Time complexity. O of n log n in all cases. Use case. Efficient for large datasets and stable, preserves the order of equal elements. Example. We have an array containing the numbers. We wanted to sort. We are going to split the array in halves until it is left in individual items. After that, we are now ready to sort. Compare their values and merge them into temporary arrays. The next step is to merge our smaller arrays into a larger one, inserting the items in the correct order. One more and we will have our sorted array. And that's it. This is our final array. Insertion sort builds a sorted array one element at a time by repeatedly inserting new elements into the correct position relative to those already sorted. Time complexity O of n squared in the worst case, but O of n for nearly sorted data. Use case useful for small datasets or when data is almost sorted. Work from left to right. Then examine each item and compare it to items on its left. Next is to insert the item in the correct position in the array. For example, we have an array that we wanted to sort. We start from left to right. Number 2 will be compared to number 8, from least to greatest. Then our first two items are now sorted. Then we compare it to number 1, which we can see is out of place. Then we swap it with number 8 until it is in the correct position from least to greatest. We have now sorted our first 3 items and so on and so forth. Quicksort is a highly efficient divide and conquer sorting algorithm. It works by selecting a pivot element from the array and partitioning the other elements into 2 subarrays according to whether they are less than or greater than the pivot. Step 1. Choose a pivot. Select an element from the array as the pivot. This element will be used to partition the array. Step 2. Partitioning. Rearrange the array such that all elements smaller than the pivot are placed to its left, and all elements greater than the pivot are placed to its right. The pivot itself ends up at its correct sorted position. Step 3. Recursion. Recursively apply steps 1 and 2 to the subarrays to the left and right of the pivot until the entire array is sorted. This process continues until all subarrays are sorted, resulting in a fully sorted array. Thank you for watching.